Hello, my name is Alan Murgis. I'm a consulting reservoir engineer and the founder of CrowdField, which is a digital hub for subsurface professionals to collaborate, develop products, and upskill. Why am I launching a podcast series around the topic of AI in oil and gas? Well, I have been an AI enthusiast myself ever since ChatGPT first came out in 2022. And I thought it would be interesting to reach out to others doing cool stuff in the AI space within our industry. So the idea is to run short sessions, about 30 minutes long, and take a bit of a behind the scenes look into the actual workflows and applications these other builders are coming up with. So the format is in each episode, I will have one guest and I will have them share their screen. And I'll be coming into these conversations from a place of curiosity. And I'll be simply guiding the conversation by asking questions from the perspective of someone looking into their stuff for the very first time. So my goal is to provide a bit of exposure for these folks to a broader audience, but also to create awareness of all the tools being developed by all these innovators. So join me, and I hope you enjoy the series. In my first episode, I talked to Sarah Tamilarasan, the CEO and co-founder of a platform called SOTAOG. Sarah built her career on global energy projects, and now she brings all her operational expertise into the AI space. Her achievements are quite impressive. She's been named one of Houston's top 50 women leaders and has the backing from the US Department of Energy, Google, and AWS. Now, I went into this session with a specific interest in how to predict bottomhole pressure using machine learning and physics. And although we couldn't dive deep into the machine learning algorithms under the hood, I was still left impressed by the platform with a pretty clean web-based user interface and a specific goal of clearly communicating value through actionable recommendations. On a side note, I have to confess that I did hit a few bumps editing around some audio glitches, so the sound quality is far from perfect, and there are also some rough cuts, but I'm learning as I go, so you're gonna just have to forgive me, and I hope you enjoy the episode anyways. Okay, Sarah, welcome and thank you for coming on the show.
Yeah, I'm excited to be here. How are you doing?
Good, good. So today you'll be giving us an overview of the SOTAOG platform with a specific focus on your bottomhole pressure prediction functionality, which actually combines machine learning and physics, right?
Right. And yeah, we'll talk about all the different inputs of real-time data that goes in, the static input of the wells, how deep it is, what tubing you put in, what casing you put in, etc., and which reservoir, of course, it's in.
Great. Okay, so we have a visual feed of your screen, so that's great. But before we jump into the screen share itself, just tell us who is this for and what are they going to learn out of today's session?
Absolutely. So we're a product that focuses on selling into the chief operating officers. So it's primarily for them. So we have several different users underneath that organization, which is all the way from production engineers, sometimes reservoir engineers, give more on the tangent, but we have petroleum engineers, operations, etc. So we sell into the group that utilizes us the most is the day-to-day operations with the predictor view. And that is sometimes fed into other groups. Like geologists, every once in a while, will be on our platform as well because they're checking sleeping. And reservoir engineers are also double confirming few of the reserves, etc. But the highest usage comes from the ops team.
Okay. So I guess there's a part which is kind of visualization, dashboard type of communication of information relevant for those users, but the ops are the ones actually clicking the buttons and operating the platform.
Yes, and we're backed by AWS and Google, so there's a lot of connectivity that is built on top. So the reservoir group actually builds their own on top of this.
Okay. All right. So I think, yeah, let's just jump onto the screen and walk us through.
Yeah, absolutely. So right away, we're taking all of the data from the customer, primarily real-time data, historical data, cash flow elements like what's the price of oil that they're working with, and so we're combining all of that in real time to tell them what the revenue is, and then we're predicting it for the next day. That's what you see up here. So you see production, you see the predicted production, and then here you look at the cash flow, you look at the change in the cash flow, you see if there's any cost that's going to impact it. You can quickly see if production went up, production's going down, etc. You have a quick view of the different weeks. So different days, you can see how much it went up or lowered by. So here's your bottom hole pressure view. As we see it, a lot of our clients, they say this is one of their favorite views because it gives them a quick snapshot of where the different wells are, which regions, the production. So if you hover over any one of them, you already know what the pressure is, you know what the production is. Your highest producers are up here. If you're going to make an investment on working over a well, etc., you might look at this group. You might look at this group, etc. This is typically used on where to drill next, sometimes, and planning and operations. So operations is looking at it on a day-to-day basis, which is the well declining faster than we thought it would, etc. That's ops view. But there's an element of planning that goes into it as well.
So before jumping on to how this information is actually used to drive decisions, just give us a bit of an explanation as to how the data actually gets here.
Perfect. It gets here so many different ways. So we can use API REST to connect into existing SCADA systems, if that's the case. We go directly to the sensors to pull that data. That's one piece of the data set. The second piece of the data set is actually a static complex data. So static data or complex data is like, how deep is your well? That's not going to change. That stays the same. What's the reservoir depth, etc. All those criteria stays exactly the same, where it's located, etc. That's what we describe by complex data sets. The pipe, etc. Anyway, and then you have the next group, which is variable operation expenses and fixed operating expenses. So fixed is like your task. Your lease operating equipment that you rent every month. Now your variable is like oil prices is variable if you're not hedged. Most companies are, I don't know, it varies from one company to another. But there's at least 20 to 40% most companies ride the market from our intel. And you have power, you have water. All of these are expenses that are changing daily. So all these elements are brought together to really look at the economics of a well. So that's essentially all the different data sets we're bringing together.
And all of this lives in the cloud, and I think you said it hosted in AWS?
Correct, right now. And it's a private cloud. But we do have connections that go back and forth between Microsoft or Google, etc., where we can push and pull different machine models.
Okay. So back to the screen. So all the information you receive is somehow, analyzed to be turned into a recommendation, which is based on actual dollar value of decisions. So there's an economic value behind each recommendation.
Right. And that's how we differentiate ourselves in the market, because I think um, calculation of virtual BHP has been around for since I started my career like 20 years ago. So they used to do it through engineering simulation, and now we're doing it through AI and machine learning.
Okay, let's focus on that specific functionality. How is it that machine learning and AI is actually used to predict bottom hole pressure?
Perfect. So a lot of the physics models are built in, actually, like, your different correlations, etc. And then there's all the other reservoir models that are also built in. But what makes it different is then then the machine learning model adjusts. Um, it's actually constrained by the physics models. It doesn't run on the physics models if that makes sense. And it looks at the real-time data, and it knows what behavior a virtual BHP should have in a certain reservoir, etc. And then it predicts that, because these models have been trained on actual bottom hole pressures, like real bottom hole sensors, and we are off by like 2 to 3%. So from that set, these machine learning models try to duplicate.
I can't quite see on the screen what is it that is displayed next to each well symbol in blue.
Did you see it now? Do you want me to expand it? So it tells you what the virtual BHP is. It tells you the well name, the barrels of oil per day, and the barrels of water produced per day.
So it's a current snapshot of the well at this very point in time.
Yes, correct.
Okay, and it also flags you, I think you said, flags you whatever well is kind of out of character related to their neighbors or their history. So something's going on with that well. The user looking into this, what additional ability do they have to interrogate further?
So, yeah. So now you have a quick look at the production of that well. You can look at the moving average. You can add more charts if you want to, etc. And you hit this. All right. And then here is now where we're using the virtual bottom hole pressure that's calculated. We're looking at the real-time data that's coming in, only the relevant points, not all of it. Okay. And we're giving a high-level recommendation. So we're saying, hey, we're looking at everything on this well, and it's a high potential well. Yeah, awesome. Yeah. Now, what do we do with it? So we're saying, hey, if you increase your frequency just by 2 hertz, you could increase your oil rate. And this is what it will look like, right? Now, here's your insights. So we're saying, hey, your theoretical gas handling capacity is X. Your PIP is 2056. Your separator efficiency is 80%. All of these look really good, actually. And your horsepower on this ESP, this is an ESP well, maxes out at 66. So you're well within the range. And we're giving this recommendation based on that. Sure.
Cool. So you have that summary page for that specific well, let's call it. You have the top dashboard, which is an instantaneous snapshot with what's happening right now. And then you have that section with the observation, recommendation, and insights. Is that also updated in real time, or what's the frequency of that?
So this is run every 24 hours. In this case, we're assuming that the client made the recommendation, changed the frequency. So guess what? The oil production also changed. They changed the frequency from 49 to 51. And this is the day before production, right? Because, I'm sure you know it. Maybe you do, maybe you don't. But, we call it yesterday's total, which is the previous day's 24-hour total in the real-time world, like you see. So you actually see that that the oil went up to higher than what we predicted, actually.
So I got a little bit confused there as to what we're looking at. So there was a recommendation, for example, to increase the pump speed or whatever. And then you have the ability to simulate what would happen if you did implement that recommendation. This actually shows you what the prediction of the system was with that recommendation.
Right. And then they made the change, right? They went from 49 to 51, and the production started to change. So it's going to be clearer after we take this out. So the oil pretty much, this is where the change happened. It was 362. It went up to 387. And now the physics principles of some of the simulations start to come in. So now you're looking at the pump curves of this particular ESV, what was built, what it was built for, what the head was, etc. We're looking at all the different recommended points across it. And you keep coming down. You look at the intake pressure. You look at the pressure gradient. And now you look at the reservoir pressure as well. And see, here you can also refresh your model. This is the bottom hole pressure, where it's doing an input for the IPR-TPR curve. And yeah, you have your different curves, oil, water, etc. And you can see that it's a high value well.
Okay. So if I got it right, the upshot here is this is already informing you of key high value decisions as informed by all the data collected from your wells in real time. And you get a daily snapshot with key recommendations, key insights, and I guess the back end is where all the magic happens with those machine learning models analyzing the humongous amount of data collected and so on.
Yeah, to come up with these recommendations and then to produce the virtual bottom hole pressure, etc.
So if we go back to the main screen with the one with which you opened, yep. So now we can understand this a little bit better. So I come here every day, have a look at this main dashboard, and color. What's the color coding there? Is it?
So it's based on the value of the bottom hole pressure. So if it's higher than 1600, there are 0 wells there right now. But lower than 1300, you've got 22 wells right now.
Okay, so it's a quick snapshot to identify, and this is a map of a certain area in the field. You can visually see which wells are doing, high pressure, low pressure.
Right. And then you do have a map, real map. I don't know if it's working, but that you can also plot your reservoir pressure on top of it. So the geologists use that a lot. Like we have a real Google map, the wells are plotted on top.
Yeah, right. And the first image above that is more of an economic. So here is production and revenue, basically. A production and revenue summary. An instantaneous snapshot of what we're doing in the field right now. And what's that first box, that percentage?
So this is a change from the day before. Okay. So we're saying is 0.7% down from yesterday. And it could just be because your gas production was down or your gas price was down. Could be, yeah.
Okay, so you have your cash flows there, then you have your quick snapshots with the bottom hole pressure, and beneath you had...
You can pull from anything that you want, or you can have your own custom one. And we're forecasting here. It's a forecast only for today. And then you can write notes to your team if you want to. They can come check, etc. You can expand, you can download. And then you can change your axis a little if you want to. Then you come down. So the functionality on each tile is about the same. We offer the standard functionalities. take a picture, download it, view it as whatever if I want. Also push to Tableau if you want to, or we have like documents already created where clients can, integrate with this right away, or we'll integrate it for them as well.
Okay. And so this is just what's happening right now. And where is it that we go into the recommended actions or insights? It's just at the well level.
So, yes. So typically for the entire business, you'll get one here when you look at that. So it'll give you a list. So today we were looking at that one well set up. And so today what we're looking at is well by well. But real clients get an entire list of all the wells, and it's color coded and it's mapped, etc.
Who are your competitors here? I mean, what is it? What software is this disrupting?
So it really depends. So first, it entirely disrupts the traditional real-time solutions that customers typically have, because you're just looking at a data, right? And you're looking at a trend, and this gives you recommendations. It also disrupts the custom build market, like Accenture, Deloitte, where you have to spend a lot of money to just get what you want, and predictions, essentially. We are seeing a lot of customers, their softwares like Crossbar, etc. We're seeing a lot of customers move to this because it does it every day, real time. Our QPR curves are built out for you every day. And you can look at the previous day, you can look at the trend, etc. And a lot of our customers, when they first come on, the technical team will go and test it. Like they'll take today's data and they'll manually put it into Prosper to see what the outcome looks like. Compare it. And then they'll do it a few more times. But we're very close. We're within 2 to 3%. So.
Yeah, because you had that little panel you showed with the IPRs and VLPs. So you're doing nodal analysis on the spot.
Exactly. Yeah. And it's not dated. It's not historical. It's real time.
All right. I think the time is right up our schedule for the session.
You're welcome to connect with me personally on LinkedIn. We're always looking to onboard new oil and gas customers. We do free trials. We show you. We'll run a demo on 10 of your wells, show you the value, build your traffic. So we're open to so many different ways because, we're very flexible. We're customer best. Or go on our website and fill out a form and connect with us. My team is also very active on LinkedIn. So they love reaching new customers as well. So we love seeing our customers excel.
All right. Thank you again for coming on, and I'll talk to you soon. Thank you, Sarah. Cheers.